polynomial in nature. So, an experienced bank auditor can check a bank's deposits twice as fast as a new auditor. Working together, it takes the auditor 16 hours. How long would it take the experienced auditor working alone? So, you understand the structure of what we're doing, that it's a work problem. We have two people working and then together. The only thing we know really is them together, yes? And together they can do it in 16 hours. So what rate are they doing per hour? 1/16 of the job is getting done every hour. Then we have two others. All we know about them is that one is working twice as fast as the other. But when we set this up, we're actually going to flip it around and talk about who's twice as slow. Because when I set this up, so however fast this person's going, this one's going twice as slow because it's taking longer. Did you see how I flipped that around in my head? So which one's going faster, X or 2X? X, right? Because 2X is taking longer, right? Twice as long. So the question says to find the experienced one. Is that the faster one or the slower one? So the experienced one is X, right? Now that I set it up, it's actually a simple rational. So to solve a rational equation, right here, 2 pages. To solve a rational equation, we want the denominators to be the same. So what do I need to multiply the first fraction by so it can match? And the answer is 16. What do I need to multiply the next one times so it can match? Top and bottom. And the last one needs an X, top and bottom. Are all the denominators the same? So the first numerator is 16. The next one is 8. And the last one is X. This can't be easier. So how long would it take the experienced auditor to do it by himself or herself? 24. If I asked for the slower one, what would you have to do? Double it, and the newer one would take how many hours? So don't think that's like in one sitting. That could take like a few days, right? And get the job done. Sometimes you think the number's too big and you're not thinking about the story in a bigger sense. You're thinking they're sitting down for 24 hours. It can't make sense, so it has to be wrong. So it could take a few days, right, to finish doing what they have to do. So don't put yourself in a box that way. So the question is, how long would it take the experienced auditor working alone? The answer is, it would take the experienced auditor 24 hours working alone. All right, let's read question number 69. AJ can overhaul a boat's diesel inboard engine in 15 hours. His apprentice takes 30 hours to do the same job. How long would it take them working together, assuming no gain or loss in efficiency? So how long would it take them working together? Now is your turn. Go ahead. I want you to set it up and you to solve it because I believe you can do it. She's going to be fine. So, can you please set up question number 69? Do you understand the structure that we're using to solve this? And there's going to be fractions. And those fractions represent the rate the job is getting done. So every hour, AJ is getting 1/15 of the job done. His apprentice, every hour is getting 1/30. And again, you can't think that he's not going to rest or it's not taking a number of days. So don't put yourself in a box that's like 30 straight hours. And then what are we looking for? Together. How do I solve this? Is by creating common denominators. So what do I need to multiply the first one times? So they're common denominators. What do I need to multiply the next one time? Don't forget the x. And what does the last one need? double check, are all the denominators the same? Now it's easy. 2x times 1, 1 times x, and then equal to 30. Combine like terms. 2x plus 1x is 3x. Divide by 3. And what did we find? So that means working together, it would take 10 hours to overhaul a diesel inboard engine. Does anyone know what that means or could do that? Because I do not. But it sounds like it would be good fun to do. All right. I need you to read number 70. Tracy can wallpaper 4 rooms in a new house in 32 hours. 4 is part of the problem, but is a fake number for our equation, yes? Together with their trainee, they can wallpaper 4 rooms in 17 hours. Again, 4 is part of the story, but not a part of the equation. How long would it take the trainee working by herself to do the job? All right, I'm going to give you a chance to set it up. You understand the structure, and we practice together. So Tracy can do it in 32 hours. So what rate is she going at? And again, don't think that's without resting and doing stuff. That's going to take a number of days. So the rate she's going at, every hour, 1 32nd of the job is done. I don't know about the trainee, but I know if they go together, it is 17. We need to get common denominators. So I'm going to multiply top and bottom times x. This one needs 32 and 17. We'll do that in a second. 32 and 17. And then this one just needs a 32 and an x. This one needs 17, right, at the beginning? So the first one needed a 17 and an x. The next one needed a 32 and a 17. And the last one needed 32 and x, top and bottom. Now, the challenge isn't that big of a challenge. Without a calculator, I want you to do that. What's 32 times 17? $14, carry the 1, 22, 2, 3. Is that 544? So 544, and on the other side is 32x. What would you do next to solve for x is you'd subtract. So 32 take away 17. That would be 15. And then the last step is to divide. Again, not unreasonable. 15 into 544. And that's a good approximate answer. So approximately how many hours would it take the trainee to complete the job? And it's about 36 hours. All right, number 71. I need you to read it, annotate it. Is this getting easier, or are we still just copying what I'm doing? Getting easier? Only way we get stronger is by practicing and then seeing if you did it correctly or not. So read it. We're not going to give our answer to one decimal place. It's fine. We'll round it as necessary. Sue can sew, which is tough, right, to read? Sue can sew. Sue can sew a pre-cut dress in 3 hours. Helen can sew the same dress in 2 hours. If they work together, how long will it take them to complete it? So I want you to understand the structure of these work rate problems, to set it up, common denominators, and solve it. Did you get 2x plus 3x equals 6? So 5x equals 6. So when you divide, how long will it take them if they did it together? So it would take a little more than an hour. Would you know how to change this to a decimal if it mattered to you? Do you know what 1/5 is as a decimal? It is 0.2, right? But that's not the lesson. So, turn the page. We have one more question that's like this. And then the next ones are dirt. And then the next ones are mixture. So I'm just trying to tell you ahead of time, you know you need practice. So last one like this, your chance. Not me. You then me. The video can run as long as it wants. I don't care. Apparently there's fast forward buttons if you want to fast forward. Right? So you need the opportunity to read, annotate, and set up the structure. This is one where you have to flip it around in our brain, right? So when I set it up in this way, X actually represents the, so the second pump takes 3 times longer, right? So X represents the first pump. So however long the first pump takes, the next pump takes 3 times as long, and then together it's 45. Did you set it up correctly? All right, common denominator, solve it, and then we'll focus on the next story problems. It's all in the reading and setup, right? Once you set it up, it should be simple, right, to solve. Make sure you know the units. What is it? Not, you could also say 1 hour, right? So it takes the first pump 60 minutes to fill the tank. If it was the second tank, what would the answer be? 180, right? 3 times as long. All right, read number 73. It should be obvious this is no longer a work rate problem, but a distance rate and time problem. A baseball question. Anyone watching baseball? Oh, yeah. Anyone worried about the Dodgers tomorrow? Me? Oh, yeah. Me? Yeah. So 2 friends decide to meet in Chicago to attend a Cubs game. Rob travels 124 miles in the same time that Carl travels 108 miles. Rob's trip uses more interstate highways and can average 4 miles per hour more than Carl. What was Rob's average speed? So I think a good way to start anyways is to organize the information that's given. And one way to organize is with a little chart. So we know distance is equal to rate times time. We have 2 situations. One is with Rob and the other is with Carl. Is it Carl? Carl. So Rob and Carl. Thank you. So start with Rob. What do we know? How long did it take him to go? What distance was he? 124. How about Carl's distance? 108. What do we know about the time? What do we know about the time? Same time? So I'm just going to use T for time. I don't know what the time is, but I know whatever it is, it's the same. What do we know about rate? In this question, what word means the same as rate? What word means the same as rate? Speed. So what do we know about their speed? Who's going faster? So if Rob's going faster, however fast Carl's going, or Rob, which one's faster or slower? So if I'm looking for Rob, then I would subtract 4 from Carl. Or the other way around, I'd add 4 to Rob, right? So if Rob is going 4 miles per hour faster, then however fast Rob's going, Carl's going 4 miles per hour less. So this shows that Rob is going 4 miles per hour faster. All right, what 2 equations do you see?
Wait, Mr. Gerson.
What happened?
If you add to Rob, would it still be the same thing instead of getting to Carl?
So if you went x plus 4 and x down here, just know that when you solve for x, it's not your answer. You'd have to add 4 to it at the end. You know what I mean? So if I decide to say x plus 4, and this is x, then when you solve for x, you found Carl And you'd have to read the question and make sure, okay, now that I know Carl, what do I need to still do to find Rob? Yes? But you get the same answer at the end. So 1 is 124 x times t. And there's the other one. So we have 2 equations and 2 unknowns. I'm going to try to make this simple. So what I'm going to do is distribute. T times x is xt, and negative 4 times t is negative 4t. Do you know a simple way I can eliminate something and solve for one variable? I don't want 2 variables. I want 1 variable, 1 equation. What would happen if I subtracted the 2 equations together? Do you see how I'm subtracting them together? Why am I subtracting them together? So let's see. So 124 take away 108 is 16. What will happen to the xt when you subtract them? And then be careful, what happens when you subtract a negative? So when you divide, what did we find? Is that the answer we're looking for? No, but we found what that's important. How many hours did it take to get to the game? 4 hours. What's my goal again? To find the speed, which is x. So can you go back to the simpler equation? And what number will you put in for t? And will that then give me the speed that Rob was going? Now, this is simpler than you think. What's 124 divided by 4? Well, what's 4 divided by 4 and 12 divided by 4? Can you see how I get 31? So what was Rob's average speed? And if it asked for Carl, Carl was 27 miles per hour. You might think that's slow, but if you ever drive to LA, think how fast you go to a Dodgers game. Have you ever tried that? One day you should try that. You're not going to go there quickly. So I hope you do get to go to Dodger Stadium. Just know that it won't be a short trip. This 74. All right, read number 74. And again, what I'm going to do is I'll put a blank copy of what we're doing today. So if you want to print it out and practice again, you can. Right now, you need to practice with me. So let's read 74, annotate it. 2 trains, classic, leave a train station at the same time. One travels 10 miles per hour. The other travels 12 miles per hour. In how many hours will the 2 trains be 44 miles apart? Oh, an important one. One goes east and the other goes west. That's another way to say they're going in opposite directions, right? All right, let's break this down. So we know that distance is equal to rate times time. We have train 1 and we have train 2. What do we know about it? So we know one's going 10 miles an hour, the other's going 12 miles an hour. What do we know about the time?
Oh, they left at the same time.
So they've gone the same amount of time. How about the distance, right? What do we know? Is that when we add this up, it adds up to what number? So that means when I go 10t and I add 12t, when I add it up, what answer would you get? So when I add it up, it'll be, right? Together they combine to 44 miles, yes? Do you see how I tried to read it well? See, I took the chart, but I kept thinking, how do I use the chart to set up to solve the question that's being asked? Now, 10 and 12 is 22. Divide by 22 and you get 2. So in how many hours? And the answer is you know these are great questions that you might see on the PSAT, right, next week?
Oh, yeah.
Number 75. We'll talk more about it as we get closer to it next week, Wednesday. Today's not, we're still over a week away. 75. And honestly, I don't know the details you kind of want to know. You know, like where are you going to be tested, blah, blah, blah. They haven't told me. So I assume you'll be in here, but I've been wrong many times. 75. So I'll read it. We only have one more page after this to do with mixture, right? So Ken and Kara are 35 miles apart on a calm lake, paddling towards each other. Ken paddles at 5 miles per hour, while Kara paddles at 8 miles per hour. How long will it take them to meet? So let's organize it and be good thinkers, good readers. So we have Ken and we have Kara. You know, when I think of the names I've never taught over 20 years, I don't think I've ever taught a Ken. Interesting? Just came to my mind. I don't think I've ever taught a Ken or even a Kenneth. Interesting, right? Details only I would care about. So what do we know about Ken? We know their distance is 35 miles. I'm going to leave that one alone. I'm not going to fill it in because that distance changes as they paddle towards each other. But I do know their rate. How fast is Ken paddling? Kara is a lot stronger. She's going 8 miles per hour. And what do we know about their time? If they're starting at the same time, right, and they're paddling to each other, however long it takes for them to meet, it would take the same amount of time. So I have Ken at 5t, and I have Kara at 8t. And if they're paddling towards each other, the distance together they are covering is 35 miles. Now, one's covering more than the other, but together they're going to cover 35 miles. And how much time would it take them together to cover that distance? So 13. Now 13 does not go into it evenly. So if it goes in twice, 26. I'm fine with that answer. It would take 2 9/13 hours. It's somewhere between 2.5 and 3 hours, right? It's more than 2.5 hours. It's not 3 hours. It's like 2 9/13. So, turn the page, or the next page. So, we have 3 more stories to do. These last stories have to do with mixture. So let's do those together. I want to get this on video, so I want to do it together. So if you want to practice, print out a blank one and go through it again because you're tired, you're not kind of listening, maybe listening, right? That when you're ready to listen and learn it, that you can. So the manager of a coffee shop has one type of coffee that sells for $8 per pound and another that sells for $13. The manager wishes to mix 100 pounds of the $13 to get a mix that will sell for $12. How many pounds of the $8 should be used? All right, so to set this up, we first need to understand what's being mixed. So first we have a $5 coffee being mixed with right? No, not a $5 coffee. $8 coffee being mixed with $13 coffee. And then the end mix is going to be worth $12. Now, in these mixing questions, there's no way the end mix could be worth like $20, right? Like, whoever the bigger number is, it has to be in between the two, right, if you're mixing them together? All right, the two things I care about in this case is quantity. How much do you have of it? Now, it's not percent, but in this case, it's money. So, when you have mixture problems, you're always going to have a quantity, and the other part might be a percent or might have to do with money. So, for the $8 coffee, do we know how much we have? And that's the question. How many pounds of the $8 coffee? So that is my unknown. But we do know how much it costs. How much does it cost per pound? $8, obvious. Do we know how many of the $13 coffee, how many pounds we have of that? Be a good reader. I circled it. It is what? 100. And how much does that cost per pound? 13, right? And then this is where the mistake can happen. The end mix, what's the quantity? It's X plus 100, right? And then what do we want the end amount to equal? How much money? 12. So here's your equation. And we multiply these together, and we add and equal. So 8 times X plus 100 times 13 is equal to 12 times X plus 100. So there's your polynomial equation. To solve it, it's a linear. We're just going to distribute, combine like terms, and get our answer. So 100 times 13 is 1,300. 12 times 100 is 1,200. Keep solving it. Good morning, Anthony. It's good that we're doing a video because I can tell you exactly how many minutes into the video you came. Yeah, no, you can see it when it's on YouTube. Everyone can see the number. The work we're doing right now is here on my desk. There's 2 pieces of paper. But the good news is, Anthony, we videoed this. So when you're ready to watch the video, at this point you can like smile that you became famous on YouTube when we get there. So 2 pages right there. So I'm going to subtract 8 to both sides. If you subtract 8, do you believe that's 4x? And if you subtract 1,200, you get 100. So when you divide by 4, how many times does 4 go into 100? So the question is, how many pounds do you need? So you need 25 pounds of the $8 per pound coffee. All right, let's try it again. Number 77. Can you be a good reader and set up a mixture problem? So we have work rate problems, we have dirt questions, and mixture problems. I need you to be a good reader, an annotator. Just circling and boxing isn't good enough. It's a good start. But now we need to organize the information. Feels like there's a lot of sniffling going on. Do you feel that in every class? Sniff, 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 sniff. Man, you gotta take your vitamins. I'm trying to walk around not so that you don't do your work. I'm doing it so that you can do your work before me. My frustration is like when you stop working, I go, whatever, I'll just do the work then. So that later on in life, you can then do the work, I guess. But I want you to have a chance to do the work. So step 1 is annotated. Hey, what's the next step is? If you are a good reader, you know what you're mixing. I'm mixing this with this to get this. So you got to be a good reader to know what you're mixing. I'm mixing this and this to get this. So set up to organize the information. A chemist needs 100 milliliters of a 60% solution. If you're a good reader, that's actually your end, right? What he needs is the end part. But how is he going to get there? Or she? It has only what? 40% and 90% available. How many milliliters of each that should be mixed to get the desired what? All right, so let's go. So we have 40% being mixed with 90%, and then the end result we want to be you don't like it? Okay. What are the two things I care about is the quantity and the percent. And this is all about reading and thinking. Once the equation is set up, it's simple. So what do I know? The 100 milliliters, what is that? That is the end what? What else do I know? Well, the easy peasy part. What is the percent we're looking at? And we don't have to write it as a decimal as long as you're consistent on both sides of the equation. So you get the right answer with 0.4, 0.9, 0.6, and the same answer if you just write down the percent. Now, let's think about the parts you have to think about. Do I know how many of the 40%? Yes or no? So what should I put down? Now here's the tricky part. Do I know how much of the other one? So let's put down y. But what I do know is that when I add them together, what's the answer? I can't have two unknowns, can I? So instead, I'm going to get y by itself. How would you get y by itself? Oh, subtract x. So instead of y, what are you going to put in instead? 100 subtract x. And now, 40 times x. And we have 100 subtract x times 90, and then 100 times 60. Do you see how I set up something very simple? So I could have one equation and one unknown. All right, solve it. We got one more to practice. So 90 times 100 is 9000 or 9,000. 90 times negative x is negative 90x. And 60 times 100 is 6000 or 6,000. Can you combine like terms? 40 take away 90 is negative. And when you subtract 9, you get negative 3,000. So when I divide, a negative divided by a negative is positive. Would there be an issue if your answer was negative here? Yes. So you're careful at the Science Center. You have to have a positive answer. And if you did something wrong, sloppy with algebra, then you go back, right, to make sure the signs are correct. So I have 3,000 divided by 50. What would be a good first step here?
60.
All right. Can you look at, like, divide both sides by 10, right? And then, you're right, 5 goes into 36, and I need another 0 to make it 60. So what's my answer? The question again is what? Find how many... Okay, back there. Find how many milliliters of each. So how many do I need of the 40%? Okay, do I need the other one too? Yes. How much do I need of the other one then? Remember, they add up to 100.
0.
So, obviously, if they add up to 100, if one's 60, the other one must be 40. So you need 60 milliliters of the 40% and 40 milliliters of the 90% to make your mix. All right, last one. So again, I'm going to give you a chance. Number 78, annotate. So be a good reader, set up the mixture question. So we're still going to have more than 30 minutes, and you're going to have the choice to keep working on the test prep packet from yesterday or Alex. And then tomorrow we're going to really work on that test prep, what you haven't finished, to make sure that you understand polynomials and rationals so you're really ready for Thursday. So once you understand your mixing, you have to be a good reader. What are you mixing? This with this to get this, right? So think through it. And this is kind of flipped around the other way, right? But we can think through it together. So I'm mixing antifreeze with 20% to get a mix at the end that needs to be 40%. At the very end will be a good thinker and reader to answer it. So do we know how much antifreeze we need? No. But the percent of antifreeze that's antifreeze is 100. It's all antifreeze. Do we know how much we need to drain or how much we need to keep? Same idea. So we don't know, so again I'm going to call that Y, but we'll change that at the end. We know the percent is 20. How about the end amount? What is the amount I need? 50, and we want the percent at the end to be 40. So I'm going to go, when you add them together, it's 50. So to get Y by itself, I'm going to subtract X. So instead of Y, I'm going to put in 50 minus X. Now when we solve this, it's going to tell me the antifreeze, and then I just need to go back in to find how much I need of the other and think through and subtract to figure out how much I need to drain. So X times 100 is 100X. 50 subtract X times 20, and then on the other side 50 times 40. So distribute, solve for X, but once we solve for X, we still have to think through what the question's asking. We're going to combine like terms and divide. I hear that. Could be mine. It's all right. So, even though it doesn't go in evenly, it actually is a decimal that works out well. So, what did I just find out was the amount of antifreeze. So, what is x equal in this case? 12.5. So it says, how many liters of this solution must be drained? That's my question. And replace. So we know the antifreeze, right, which is x. Then what is y equal if I go 50 subtract 12.5? We're still not done thinking. 50 take away 12.5? 37.5. What did I just find with 37.5? 37.5 is what needs to stay in the tank. So how much needs to be drained then? If I have to keep 37.5, how much needs to be drained? Well, how much was in there to begin with? So it goes back to what I did before. How many liters need to be drained? So you need to drain 12 and a half. All right, so those are practice mixture problems. So Mr. G Math over and out.